So for this problem, we need to design a number container system that can do the following. The first is that it can do the insert or replace operation. Basically, it's going to be insert or replace a number at the given index in the system. Yeah. And the second is that we're going to return the smallest index for the given number in the system. Yeah. Currently, we don't understand what we are doing, but let's just check this number container class. So it's gonna have a change and find. So for this change, it will fill the container at index. So for example, currently index 1, we're gonna fill a number 10. At index 2, we can fill a number like 20. Yeah. So this is the operation of change. So if there's already a number that exists at that index, so we're gonna replace it. So currently, if we have an operation of index 1, 20, so we're gonna replace this 1 with 20. So this is basically the change operation. And for the find, we're gonna return the smallest index for the given number, or -1 if there's no index that is filled by number in the system. Yeah. So for find, for example, we have an index. So for example, we have a number, for example, 2. And we're gonna have index like 1, 2, 3, 4. Yeah. So basically, we are giving we need to return the smallest index, which is gonna be 1. So if the array is empty, basically we're gonna return a -1 because there's no index. Yeah. So this means for this problem, basically we need to use index to find the number. So this is the index to number. So another way is we're gonna use this number to find the index, but we need to find the smallest index. So this means basically we need to use two dictionary to solve the problem. Yeah. As we are going to find the smallest index for this number. So for example, this is a number, and for the value it's going to be a list. But we need to find the smallest index. So this means we can use a sorted list in Python to solve the problem. Yeah. So basically we need to have two dictionaries. So first of all, we're gonna have index to number. So it's gonna be a default dict. I will give a list. I will give a number. Yeah. So this integer. This is gonna be the first dictionary, and the second gonna be the number to index. So it's gonna be a default dict, and I will give a sorted list. Yeah. So for this sorted list, we need to import from the in Python, because currently in Leetcode we cannot do that. Yeah, so we need to import it. So from sorted containers, we need to import the sorted list. Now we can directly use it. So number to index is going to be a dictionary, and the value going to be sorted list. And index to number, so the key going to be index, and value going to be the number. Now we need to do two operations, do the change and find. So let's just check the find first, because this find is going to be easier. Yeah, so for example, if we are giving this number to index, so basically it is like this, and we need to find this number too. Basically we're going to return this one if it exists. Otherwise, so we're going to return a -1. So let's just solve the find first. Yeah, we just need to find the number and get. So yeah, let's just imagine if change can help us to do everything. So we just need to check this find. Yeah. So for the change, so for example, currently for this index 1, we have a value of 10. Now we want to change this index 1 to 20, change the value to 20. So this means for the value 20, if inside there's the index 1, we need to delete it. Yeah, maybe it's going to be index 2, 3, or others. Yeah, so this is what we are doing for the change. But currently, let's just finish the find first. Yeah. So for the find, basically we need to return the self.number to index with this number, and we need to return the first value 0. Yeah. So if this exists, yeah, because we are going to return the smallest index. So if this number exists, basically this is a sorted list if it exists. Otherwise we're gonna return a -1. So the find is gonna be easier because we're gonna do everything like normal. like normal ways, we're gonna do everything inside of the chains. Yeah. So for this chains as my example, so for example, currently I have index 1 with a value of 10, and next I'm gonna update this value with index 1. So for example here, I'm gonna update this index 1 with a value of 20. Yeah. So what I can do about it? I can directly do it, right? Yeah. So let's just do it. So self.index to number. So we're gonna use this number. We're gonna update it to the index, and self.number to index. So we're gonna add. A number to index. First of all, we're gonna find the index, and we're gonna add number to index. We're gonna use this number. So we're gonna use this number to add the index, and the index to number, we're gonna assign the index as k, and we're gonna have a value of this number. So this is gonna be the first operation, right? So for example, this is a 1 currently inside my value array. So for example, this is a 10, and I have some index like for this example, maybe I have 1, 2, 3, 5. Yeah. So this is the first example. I have value. This is the number to index. So for number 10, I have value. I have an array like actually it is a sorted list. It's gonna be 1, 2, 3, and 5. And I also have a map like index 1 to 10, 2 to 10, and 3 to 10. This is the index to number, right? And 5 to 10. Yeah. So this is currently the operation. Now I can do this find operation. So for example, I can find 10, which is gonna return a 1. So this is a 1. Now I'm gonna do a change. So this is important. Yeah. So if I were to do this kind of a change operation, basically I were to change 1 to 20. So here, index to number, I'm gonna change this index with 1 from 10 to 20. So this is okay. Now from number to index, I'm gonna add this index. Yeah, so this is the number to index. I'm gonna use this 10 to add I'm gonna use this 10 to add the index. So currently I have like 1, 2, 3, 5. Yeah. Now I want to add this index 1. So this is the number to index. I need to add this number. So this is a 10. I need to add this index 1 again. So this one gonna be inside the sorted list. Yeah. So this is currently what I'm doing, but this is wrong, as we can see from it. Yeah. Because for this index 1, the value for this 10 has been updated to 20. Yeah. So this means inside this 10, basically I should not have the index 1. So if I were to find this 10, basically I should not find this 1. Instead of 1, I need to find this index 2. Yeah, because currently I don't have this index 1 because this value has been updated to 20. Yeah. So for example, for this value 20 array, I think I did something wrong. Let me just clean it a little bit and make it right. Yeah. So currently for this operation, so the number to index, so currently for this 10, it's going to be 1, 2, 3, and 5, right? And for this 10, we're going to add index, which is going to be 1. So this is exactly what we are doing. Yeah. So this is the number to index dictionary. Now, if we are going to find this 10, definitely we will not return 1. We're going to return this 2. So this is for last find. So for the last find, we're going to return the index 2 instead of 1. But how can we remove this index 1 from the value 10? And this is also easy. because we just need to remove this this index 1. But how can we this means we must remove this index 1, and then if we are going to call the file with the 10, definitely we're gonna return an index 2, so instead of a 1. But how can we remove this index 1? So this means currently for this index we're gonna assign a number. So for example, this number is gonna be 20. But what is the previous numbers? The previous number is 10, and how can we find this previous number? Because currently this number is 20. So for example, so here we're gonna assign this number from 10 to 20, but we need to find the old number, so it's gonna be 10. So if we can find the old number, so it's gonna be 10, and we can use this 10 directly to remove the index with this 1. Because we can find the old number. If we can find the old number, definitely we can remove the index, because this is a sorted list. Now let's just change a little bit. So we need to find the old number. So for the old number, we're gonna use here index to number. So we're gonna use this index to number to first find the old number, and then we're gonna use this self.number to index to remove that index first. Otherwise, we're gonna return a wrong file. If we were to find, we're gonna return a wrong answer. So the self.number to index with the old number. So here in this example, the old number is gonna be 10. So it's gonna be remove this index, which is gonna be 1. If we remove this index 1, so currently for the next file, if we are going to find this 10, definitely we're gonna return 2, because this one has been removed. But we need to check if this index, we need to find this index inside of the index to number. We have to check if it exists or not. So this means we need to check if this index inside the self.index to number. So we will do the following 2 operations. So we're gonna find the old number, and from the old number we're gonna remove the index, and then we can simply to do the operations of self-index to number, we're gonna assign this index to our new number, and we're gonna add the index to this new number. So this means it's gonna be okay. Now let me just run it and submit it to check if it works. Now as you can see, it works, and it's pretty fast because we are using the sorted list. Basically, it is the n log n time. So this n is going to be 10 to the power of 5, because they're going to be where is it? They're going to be 10 to the power of 5 calls. So this is and the log n is also, we're going to make it 10 to the power of 5. This is why it works. So this is going to be the first idea, which is going to be a sorted list. So for sorted list, basically it is a balanced tree. Because for a balanced tree, we can do the remove and add operation in log n time. So this is why in Python we can use a sorted list. But we can also use priority queue to solve the problem. Now let's just delete the sorted list and try to use priority queue to solve it. So it's going to be the same idea, but for this change, we need to delete these areas, because for this change we don't want to do all those kind of operations. Because if we are going to use a heap, we cannot do this change with those operations. Because this is a sorted list, we can do that easily. We can remove this index. But if it is a heap, how can we remove this index with log n time? It is impossible. So for the priority queue idea, we're going to use the lazy delete of the heap. So if it is a heap, we're going to use the lazy delete. So for the change, we will not delete it. Instead, we're going to delete it from the file. So everything going to be okay. We will prepare the index to number and the number to index. So here, instead of a sorted list, we're going to make it a list. Yeah, because currently we are going to use the priority queue to solve the problem. Yeah. Now here for the change is okay. So currently we are doing such kind of operation. So for the index to number, so we're gonna have let's just 1 to 10, 2 to 10. We are doing this kind of operation, and then 3 to 10. Yeah, we just do this kind of operation, and 5 to 10. So this is the index to number. Yeah, if we are going to call this change, we will do following operations. And the number to index, so for this number to index, for this 10, it's going to be 1, 2, 3, and 5. Yeah. So these are the two operations, the first and the second operation, index to number and number to index. Yeah. So currently we did the change operation. Now we are going to do this find operation. So what we are going to do? So we are going to find this number. So currently we are going to find this number 10. Yeah. So if we are going to find this number 10, basically we can directly use the self.number to index. We're gonna use this number with 0. So this is gonna be the final answer if it exists. Yeah. So we're gonna return a 1. So this is okay. Now let's start to finish these areas first. Yeah. So let's just use a heap. It's gonna be this one, self.number to index with this number. Yeah, so this gonna be a heap. So we're gonna return heap 0. So if this heap exists, else we're gonna return a negative 1. So basically, at least this one must work. Yeah. So for this 10, definitely we can return a 1. Yeah, because according to our yeah, this is not okay. I didn't find my examples, but yeah. So for the examples, let me just make the drawing again, maybe. Yeah. Yeah. So for the examples, like we have 1, 1, 10, like here 2, 10, and here we have 3, 10, and here we have 5, 10. Yeah. And for the number to index, it's going to be 10, and with 1, 2, 3, 3, and 5. Yeah. So this means if we are going to call this find, we're going to use this heap, and this heap is going to be this heap 1, 2, 3, 5, and we're going to return it's 0. It's going to be index 1 if this exists. Otherwise, we're going to return a negative 1. So currently, what happens if there is another change? It's going to be so the change is going to be 1 to 10. So instead of this 10, so currently for the index 1, it's going to be updated to this one. Yeah. So instead of 10, it's going to be a 20. Yeah, because here we're going to have a change. Yeah. Now we are going to call this 10 again. We are going to find the 10. Yeah. So definitely we're going to return 2, but not 1. But how can we return how can we return an index 2 instead of 1? Yeah. So this means from the find we need to know. Basically, we need to know on the first index. And because normally for this heap, definitely if we are going to call this number 10, we're gonna return the smallest index. Yeah. So similarly, we are going to check the smallest index, but we're gonna check the values. Yeah. So you know from the beginning, while we are using the sorted list, we are checking the odd numbers. Now actually we are checking the odd index instead of the odd number for this find method. So inside of the find method, we're gonna check the first index. We're gonna check this index. It is 1. Okay. And we're gonna check the value of this index 1. So currently this value for this index 1 becomes 20 instead of 10. If it is 20, this means this 20 is not equal to my current number. So my current number is 10. So 10 is not equal to 20. So this means the value for this index 1 must be changed. So if it is changed, this means we cannot use this index 1. So we're gonna pop it out. So we're gonna pop it out, and we're gonna use the second index, which is gonna be 2. Now, yeah, we're gonna think this 2 might be the smallest index. So we're gonna check the value again. So for this index 2, we're gonna check the value. It is 10, and here the number is 10. So it is the same number. It means this index has not been changed. So we can safely return this index 2. Yeah. So if this value maybe is 15, we're gonna check the next index 3. Yeah. So this is the basic idea. So how can we check that? We can directly check the heap. So while heap exists and it's 0, let me think about it. Yeah, it's 0 gonna be the index, and we're gonna use the self.index to number to find the number. Let me just copy it. So the self.index to number with this it's 0 is gonna be the old number. I'm gonna check the old number if it is equal to my number. Yeah. So I'm gonna pop it. I'm gonna use a heap pop of the priority queue. Yeah. So the idea is that currently I'm gonna check this heap. I'm gonna check the first index 1, and I'm gonna check the number. It is 10. Yeah. But it can be updated to 20 in this example if it is updated to 20. So what's going to happen, because 20 not equal to 10, we're going to pop it out. Yeah. So this means we're going to pop out the smallest index 1, and we are going to check the next index. So for this 2, the value is 10 equal to 10, so it means everything's okay. We are not going to pop it out. Yeah, and similarly for others. And this exist. Yeah, so for this one it is not equal, definitely we're gonna pop it out. And then we are safe and we're gonna use the second index. Yeah, because here this is equal. For the second one it is equal, so we are safe and we're gonna go out of the while loop. So if it is still not equal, so we're gonna pop it out and we're gonna check the next until we find the answer. Maybe index 3 or 5. It is okay. Yeah. Now let me just run it and check if it works. So here we can only use add, and definitely we're gonna use the heap operation. So we're gonna use heap push with the self dot number to index with this number, and here we're gonna use the index. Yeah, because currently it is a priority queue, we need to change it to heap operation. Now as you can see it works. Now let me submit it. Yeah, as you can see it works, and even it is much faster than the sorted list. Yeah, because basically the heap gonna be faster than the sorted list, because sorted list gonna be a balanced binary tree, and it's gonna be slower. But for the heap operation, basically it is a array. Yeah, for the heap. That is why it is so fast. For this problem, basically the heap operation gonna be the best operation, and especially for this delete operation. Instead of a change, it is a delete from the file, and this is really difficult to think about it. Normally we think about the sorted list, we're gonna delete it, the index from the change. Now we're gonna delete the index from the file, and actually this kind of method can be used to solve so many Leetcode problems. So we're gonna call it a lazy delete. So instead of delete it from here, we're gonna delete it later. Yeah, I think that's all about it. Thank you for watching. See you next time.